Okay, hello, professor or grader. So let's just go ahead and jump right into it. Here is my user interface. I use Adobe Flash to create this, and as you can see, we have a difficulty, we have a puzzle. You can go in and actually set these yourself, and it will automatically update. We have our data here, time, length, space, and then we have our search algorithm. So let's go ahead and just run a couple of these real quick. I'm just going to run breadth of search on medium difficulty. As you can see, our success path popped out with the direction that came before it, and it'll print out everything and solve it until we get to our solution there. So let's go ahead and just run, so if I want depth first search on hard, let's go ahead and run that. We've rented that out, printed the data, so let's go ahead and jump right into the code. Here is an overview of the structure. So basically you have the .fly, which is the file I just showed you. That'll be a .swif when I package it. And we have our main, which kind of renders all the data. We have a renderer that renders the graphics. And then we have our 8 puzzle algorithm base class, which is extended by breadth of search. And then we have a trail here that gets implemented, gets extended also. The puzzle algorithm base, as you'll see, will have the basic data needed for all of these. And I have a heuristic variable function and a successor variable function class here, which is going to help me abstract out my search algorithms from the 8 puzzle. So let's go ahead and jump into some code quickly. So here is the main. A lot of this is just rendering stuff. You can take a bigger look at this yourself if you want in the class, but let's just go ahead and jump to the start puzzle. So as we can see here, we are getting our successor functions. This is just going to be the 8 puzzle, and we're getting our heuristic function, which is given by the front end. And then we hit our algorithm, and we're just going to go ahead and run whatever algorithm was selected out of our algorithm factory here. As you can see, we have the classes being loaded up. So let's go ahead and just jump right into that. Let's start with breadth first search, since most things implement from that, or I'm sorry, extend from that. Let's see. So we have a run function, which is our starter. Actually, let's go ahead to algorithm base first, so we can just see what's being grabbed here. We have a successor function, heuristic function, goal state, iterator node, visited nodes, which is a map. 0 is unvisited, 1 is visited and popped from the queue. We have our queue, which is a linked list. We have max queue length, solution length, max traversal depth for iterative deepening search. And then we have some functions here to be overridden. And let's jump into our run. Set goal state, set the heuristic function, or sorry, set the successor function. Get the first node on there. Pop the first node. Check if we have seen this node. Then we hop it on. We go to our successor function, and basically the successor function will alter our visited nodes and everything else, and get us the next nodes. So let's go ahead. When you look at that real quick, this is the successor function I was talking about. That's abstracted out of the breadth of search algorithm. So let's just go ahead and look at that very quickly. The 8 puzzle successor function. This is solving specifically the 8 puzzle. And then, as you can see here, where's the queue? It gets popped off, removed first. We can look at depth first search quickly. It's getting popped off last. We can look at iterative deepening search. We have while finished, while unfinished, resetting the stack, the queue, and then going back into everything. We have our, what else do we have here? We have our best first search, which is using a heuristic function here to order the queue. and you can imagine A star doing a very similar thing that's on the code. And I've just come up on my 5-minute mark here, so I'm going to hop off. I think that was a decent demonstration. The rest should be on the code, and I'll make sure I get all these documents to you. And thank you very much. Okay, hello, professor or grader. So let's just go ahead and jump right into it. Here is my user interface. I use Adobe Flash to create this, and as you can see, we have a difficulty, we have a puzzle. You can go in and actually set these yourself, and it will automatically update. We have our data here, time, length, space, and then we have our search algorithm. So let's go ahead and just run a couple of these real quick. I'm just going to run breadth of search on the medium difficulty. As you can see, our success path popped out with the direction that came before it, and